The techniques and the capabilities are changing so fast, even within the last month, right? It's a string. It should be, an enum, or it should be something else, right?
So essentially, this is just replacing ClickOps with ChatOps.
And it missed some very important steps.
Maybe an LLM to retrieve this information and developers interacting with natural language might be the future.
If you need to parse a source file and figure out what classes are defined within the source file, and you have access to a TypeScript compiler, use a TypeScript compiler, right? Who's the owner of this code generated by the LLM? Instead of casual Fridays, there should be a no LLM Friday.
Maybe 5 years down the line, nobody really knows how Kubernetes works, except for the Kubernetes maintainers or developers. Rogue agents is something futuristically that we all can be worried about at some point. Hey everyone, welcome to the first ever episode of AI in DevOps Podcast. In this podcast, we explore how AI is reshaping the way we code, build, deploy, and operate. I am Rohit, your host. I'm the co-founder at Facets.cloud. And why this podcast is something that we want to cover. So everyone is talking about AI like it's magic, right? But not enough people are talking about how it actually fits into day-to-day DevOps, even the messy parts, the trade-offs, and the real impacts on teams, on how they operate and things like that. So that's what we are here for. We want to hear real stories, honest takes, and zero fluff. And this is a perfect segue into introducing our guest for the day, Vincent De Smet. He works as a DevOps engineer in Handshakes.ai. And moreover, he's very opinionated and straight talking and has very hot takes. And most of them are very spot on, given his years of experience in the space. Let Vincent introduce himself. Maybe Vincent, tell us about a little bit of your past and what you work on.
Yes, thank you very much for this introduction. I started in DevOps space when I started learning about Docker for a friend's startup. And then after helping to organize some meetups, I'm based in Vietnam, and I helped to run some meetups about Docker in Ho Chi Minh City. And from Docker in around 2015, Google introduced Kubernetes, and that was a very exciting framework. So I focused on, after proposing to talk about it at one meetup, I actually got really, excited about the capabilities that Kubernetes offered, mostly thanks to people like Kelsey Hightower and Brandon Burns. I watched many of their presentations on introducing the concepts behind Kubernetes and the concepts behind CoreOS when Kelsey was still at CoreOS. And I was briefly a Docker captain as well. I looked into the way that the Docker client for Windows was written and found that the Samba password, like the share, was actually accessible for users, and that's something they patched later on. So it was actually very interesting, early stage, identifying some of these problems and then also being asked to be a Docker captain for Docker. But I then moved to Singapore to focus on actually running Kubernetes at startups, and then also running Kubernetes with Terraform at startups, and mostly on AWS. So that's most of my experience is on Terraform, Kubernetes, and AWS. And I then stopped being a Docker captain, but focused more on cloud native landscape with Kubernetes and Kubernetes meetups in Singapore, where I joined the startup. And then later, during COVID, moved back to Vietnam working from home. And now focused, of course, also very excited about the capabilities that AI open up for us. And that's what we are also exploring currently at Handshakes.ai, where we are using Terraform and AWS mainly and we're integrating AI onto our daily work as well as developers and DevOps engineers.
That's great, Vincent. And I would also love you to talk a little bit about Terra constructs work on.
Okay, so after working with Terraform since about 2016, running Terraform since version 0.7, Terraform backends weren't really established yet. The concept of having an S3 bucket to store the state, it was not as polished as it is today. Also before, Terraform 0.12, for 0.12, HashiCorp language was very static, didn't have the list comprehensions, and for each statements that didn't exist. So at that time, we used Terraform heavily, and we got used to evolving our Terraform configurations. And I saw that adoption with other engineers. Like we did actually run workshops at the first startup on how to write Terraform, and we built Terraform modules for the teams to deploy their classic golden path product deployments. But the Terraform modules were always a little bit of a difficult beast to manage. It's a very simple or a simplification of what they refer to it as like a class or a bundle in Ruby, but it's actually very limited in its capabilities. So when I then came into contact with AWS CDK at another company I was at, then I noticed that this was introduced by engineers themselves. It was not coming from DevOps teams. The engineers themselves working on AWS decided that they wanted to use AWS CDK. My initial feedback to them was, please, can we just stick to Terraform, because we have a lot of tooling around Terraform, like Atlantis for Terraform automation. You're introducing a new tech stack here. Can we just maybe look at Terraform CDK instead of AWS CDK? Funny enough, you know how this goes. 1 week later, a pull request comes in. Guys, I've done everything with AWS CDK. So great. Now, please, can you automate this? Like, can you put it into the CI/CD pipeline? So I noticed I was initially not very happy, but then working with it and then making, building constructs, building reusable patterns. I very quickly noticed that a lot of the engineers, the product engineers, jumped in and introduced new features that they wanted. And they could do it easily because they were able to just, build a TypeScript class, build a utility function to their, just the same way that they write the product features. There were a lot of Kotlin engineers and TypeScript engineers, and they were writing unit tests in Jest. So they were already using those tools, and they were very quickly adopting those things. And I loved AWS CDK. I loved the adoption. Within months, we got a lot more adoption by product engineers compared to our Terraform that existed for 2 years, where, most of it was delegated to platform engineers to go and figure out what exactly are the API resources that we need to create to do something. I know this podcast is about AI. Maybe we need to come here. But basically, to cut things short, I loved AWS CDK, but I did not like CloudFormation so much. And it also caused problems interacting across the different technology stacks. So that's where I started playing with the idea of I use Terraform CDK, but obviously it's lacking a lot of the capabilities of AWS CDK. So I started copying over the beautiful work that AWS has done on top of the CDK, on top of the construct, and reworking it into the actual Terraform resources, like the Terraform CDK resources. So that's what Terra Constructs is. It's currently mostly an AWS port of AWS CDK on top of Terraform CDK. And I'm also employing now, after doing this for 7 months manually, focused on LLM workflows to automate this work, because a lot of this is very tedious and repetitive work. So LLM workflows are really accelerating or empowering the engineers to adopt or do this very tedious tasks. Yes. So you asked me to talk about Terra Construct.
Yeah. So I'm genuinely curious as to learning how much of Terra Construct is now being vibe coded.
Okay. So I have not yet adopted the vibe coding vibe or a hype. I am very firmly asking LLMs to generate the code separately in a chat window, and then I read every line and I understand every line, and then I take the parts I like. I will admit that some parts of the LLM workflow that I wrote actually ask the LLM to generate hey, I need a way to extract, using the TypeScript compiler, I need a way to extract all of the classes that are being used. Like, I have an import statement. I want to figure out where this class is being used throughout the TypeScript file. And a lot of that code was vibe coded. Okay, so I lied, but not in my daily job, but in actually writing the LLM to generate conversions, I used some vibe coding, but in my day job, I still very much want to understand every line of code that is generated. But I do find that it really helps late at night when I'm thinking about some algorithmical problem and I really want to meet this deadline. I know that oftentimes you go to sleep, you wake up, you're a fresh mind, you can do it. But sometimes you just want to push for a deadline. And so there, I really find this vibe coding where you can just throw the problem at the LLM, go away, get a cup of, not coffee that late, but water, and then actually come back and see something and then read how the LLM, so often it gives you multiple options. What are the trade-offs between them? I really find that helpful. But I don't trust it to completely generate my code base yet because I want ownership over it. I want to control it.
Right. In my personal experience as well. So I think I did start off with, as you said, working on a chat window, getting some snippets generated or scripts generated, and then integrating it with my code myself. Then also, slight segue, I did also try out tools like Cadence GPT, which give you a chatty interface with Kubernetes or get actions done or retrieve information from them. Then I found that I slowly start weaning off those and get back to my data. I kind of felt that my CLI hands are faster than my chatting hands, and get back. But then off late, with the advent of MCPs and a little bit more control over what I can let LLMs do and whatnot. We have dabbed into getting LLMs write complete Terraform modules with some safeguards on top of it. Like, for example, we make sure that the tools provided to the LLM invoke the Terraform validate or run checkoff, so that I have certain guarantees that it will go back and correct itself and generate something to my standards, right? So that is one direction that I have found a lot of promise. I agree that losing ownership of your code is something that is a danger with LLMs. Yeah. So this is a direction that we have been exploring at Facets as well, and it looks promising, actually, Vincent. And I think you have also recently done a lot of research on how to get good infrastructure as code generated, or what are the pitfalls associated with it as well. So what did you find on that?
Yes. Before I get into, I think two things about. I think it also very much depends on your mood, like how fresh you are, how like what. Because do you want to think about this hard, or do you want to let some like LLM do the thinking real quick for you? Because in 5 seconds it can come up with some ideas that helps you get something to get started, right? And the second thing is, I think that everything we discuss, it may completely change next month. If we go back to a month ago, there was no 1 million context Gemini. Now everyone is pushing 1 million context Gemini. The techniques and the capabilities are changing so fast, even within the last month, right? We can go back and look. I look at, podcasts that people, before this podcast, I look at podcasts about this topic from a month ago, and I'm thinking to myself, oh my God, so much has changed already 1 month. Right. So yes, like you said, I think it is improving quickly. And so this is whatever found that works today, we always have to reevaluate that. Is this still the best way of doing things? Maybe today I can just take the whole document and paste it into ChatGPT, and it will then, or I can put it as a markdown in my editor somewhere and point to it and then tell the agent, go ahead and read this, and then go and generate me some more files. To the point of what you just ended with, what are some techniques that we can use to improve the quality of the code that is being generated? I think everyone always says context is king, right? And that's definitely something that I always do, is try to find relevant documentation. I often, from a documentation website, go to the GitHub page that backs it, because a lot of documentation websites today, there's like edit me here, like at least with open source, there's some link back to an open source GitHub repo where I find the original markdown with some front matter. Actually, all of that is great. I just take all of that, just raw copy the code, and put it straight into the context for my LLM to act on, and to be more knowledgeable about what type of decisions or what type of code it's going to write. So again, also every major AI provider like Cloud and OpenAI and Google Gemini, they have all published prompting guidelines to control the quality of what you're getting. So does that answer your question about like techniques to improve the quality? I think that was
right. Right. And I think you've also done some research on, Terraform languages like Terraform, like DSL specific generation, which are niche sort of. You don't have a lot, LLMs do not have a lot of Terraform code base to learn and understand from. So that on that lines as well, you have some insights, right?
Yes. So a lot of companies today, they are rightly pointing out that most of the Terraform infrastructure as code is private to companies, because infrastructure is a sensitive topic. So a lot of the really production ready infrastructure and compliance ready infrastructure is not publicly available. And LLMs are trained on what's publicly available, or what is available to the company, training the LLM. I don't know how they get access to some of the data, but okay. So another point that was highlighted by one of the podcasts I follow was that less than 10 or so, I don't know how many, but like there's a limited amount of public available, production ready modules. For example, the Terraform modules. I know the work from Anton Babenko is doing a lot of effort there to make them, production ready and good code. But still, compared to like what you just highlighted, like the comparison between generic programming languages like Python, JavaScript, and so on, compared to the amount of code that's available to train on, like HashiCorp language or Kubernetes YAML, there's a big difference between the amount of data to train on. So I think I have a different opinion there than most of what some companies are focused on. Is like, hey, we need to use more deterministic methods to guide the model. Some of the advice was to give them grammars, definitions, so that the model can follow those grammars and then generate code accordingly. I am more of the opinion, I look at LLMs like junior engineers today, right? And that the same way I saw that AWS CDK empowers these product engineers that are not necessarily experts in infrastructure as code suddenly became way more powerful when they started using a generic language like JavaScript, in this case TypeScript or Python. So I think that's where AWS CDK is very valuable, and it's also another reason why I focus on Terra constructs, because I believe that instead of using DSLs, we should be focused on building more of these higher level libraries. That's basically where I wanted to go with that.
Yeah, that's interesting. So you would rather have LLMs write Node or TypeScript or Python that uses CDK or CDKTF rather than write vanilla Terraform.
That's right. So I think you can argue like if you train an LLM properly, it can generate perfect Terraform that is valid Terraform, and it's able to run against the cloud and can deploy infrastructure, rather than generating Terraform, which I think is a low-level abstraction of direct resource against AWS CDK. Against cloud provider APIs. I think leveraging higher-level libraries where there's more of the ideas of what the API resources represent, and in this case, AWS CDK is maintained by the AWS, so they are really having a very good visual, like a very good interface, which is the same for developers and is the same for LLMs. These interfaces and these JavaScript documents really help as a proper software development kit you to create infrastructure. The same way that you would click on a button in the AWS console, you get an piece of infrastructure and all of its capabilities like connected to each other. Unlike Terraform resources where you have a string variable, and then that string variable has a documentation that you need to go to the website for, that then explains the valid values for this string are all or none. And then, it's a string. It should be, an enum, or it should be something else, right? So that's better captured in like software development kits and also better visualized in actual programming language.
Yeah, that is actually interesting. It makes me think. So as I mentioned, we did dabble into getting Terraform modules generated by LLM with MCPs. So one of the tools that we gave it was that, hey, when you create variables first, you model your module first, and then make sure that all of the validations that are required for your variables are there. And the moment he adds resources, or the LLM adds resources, I also prompt engineer it to sort of make sure that it adds all the respective relevant lifecycle hooks, as well as pre-post validations. So this made it write a lot more mature Terraform than what a human would write. And yeah, I see what you mean. So rather than do this, what you suggest is write in whatever programming language the LLM is fluent in, and use the underlying SDKs to generate synthesize the Terraform.
Yes. The reason I believe that is more powerful and more generic is because aside from the LLMs being trained on it, you also get more determinism by the SDK and the library itself. So the idea here is not to have this complete non-deterministic behavior of an LLM, where it is not necessarily correctly linking your Terraform resources together. Again, because a lot of it are strings, and maybe you are doing a lot of prompt engineering to ensure that the strings are valid and that the resources are linked together correctly. It's still non-deterministic. Again, everything I say today could be not true in a couple of months because of the LLM has become so powerful that it can actually handle a lot of that. But then we can discuss about code ownership more later. But if you actually have a library like an SDK or a CDK that has, validated patterns, that the code it generates is validated with E2E testing, and it's trustworthy, it is maintained by the cloud themselves, ideally, like AWS CDK, then you get a lot more powerful and maintainable code, because you're working with a higher level library that is achieving these capabilities in a well-tested way and in a more native way for LLMs to work with. That's my opinion.
Yeah, that's very thought provoking, to say the least. And yeah, so as a segue from over here, so you also are passionate about making the product developers, enabling the product developers to make some infra changes themselves. The true platform engineering concept, or where they get involved and they can raise pull requests. Maybe they write CDKTF code or AWS CDK. Now, how do you think that is going to so now with the advent of AI, how do you think that is going to change a little bit? So the way you deliver you as a platform engineer deliver your services or your automations to the developers to consume, how do you think that will change? Or is it just going to make it a little faster because AI is there, or is it going to fundamentally change how your platform engineering would look like in, let's say, a year's time?
Yes, I think we can see that LLMs having the capability to take more or to guide developers better into adopting these IAC patterns or to develop their own or take more responsibility of their infrastructure in the cloud. It may change the role of platform teams slightly because basically I think the role of platform team has always been to provide tooling and golden paths and guardrails to ensure that these are secure. So, as you mentioned as well, that even though you are trusting an LLM to write your infrastructure as code, you're still giving it tools to run checkoff, which is a tool to statically validate or evaluate the security of the generated configuration, right? So these guardrails, you can do them completely shift left, like you're doing, completely integrated at the early stage when you're writing the configuration. But they can also be, they're still applicable towards the deployment side of things, where when things are running, you have platforms like Wiz or other cloud scanners that validate. I only mentioned Wiz. Basically, you have cloud scanners or security tools that are living in the cloud to validate that there is no configuration that violates this. So we do this early with the tooling, like you mentioned. And as platform engineers and as security engineers, I think oftentimes these roles are combined to make sure that we are compliant. We are still putting in place these security guardrails. I think the focus that this might pivot more towards making sure that we are providing the context. I think as a platform team, currently we are building tools to provide context to developers so that they are aware of like, this is how a landing zone is provisioned. This is how I provision my default stack or preferred golden path stack. I think that that's really providing context to developers to really know where do they go for the dashboards, for the observability. That's a platform engineer job today, right? And now maybe we will be more focused on integrating these context providers for LLMs that the engineers are using. So the engineers will use LLMs and they need to pull in the context that the platform team is building, right?
Right. So potentially in the future, platform engineers could be developing MCPs that are made available to the development teams who can interact with it in probably natural language and in English and express the desire
Yes.
and get the things done. But then again, the MCPs should include all the guardrails, validations, to make sure that it propagates the right way, right?
Yes, and that's very often very internal to each company and something that is not easily opened up by most companies. So similarly, like in the past where a lot of companies prefer to run their own CI/CD runners, prefer to, manage their own security data or like personal identifiable data from clients, they are responsible for this, right? So that's why a lot of these context providers or model context protocol providers will need to be managed internally, I think, because it would be very difficult to trust third parties to provide these, right? I think there can be contracts to. I think it depends on the size of your organization and the capabilities of your organization and how far this will be internal or vendor provided.
Yeah, and also while we are on the topic, there are also many products, companies coming up with products which are more ChatOps. Get me an S3 bucket, and I'm able to spin it up in AWS with and things like that. Do you think this is going to devolve into basically ClickOps of the yesteryears? So essentially, this is just replacing ClickOps with ChatOps. Do you see that as a threat or a danger where companies take the shortcuts and end up with some unmanaged infrastructure that is all provisioned and managed by LLMs?
So I think this could be tied back to a larger approach of the company itself towards these LLM platforms. If these companies provide or integrate LLMs as a way of working with the infrastructure within the company, and by this I mean actual proper contracts in place of how engineers can use those LLMs, then they probably can control more how these LLMs will be used to provision infrastructure and avoid these problems. But if the companies are not taking into account the usage of LLMs and ignoring the problem and telling people you cannot use LLMs, but I see constantly people finding backdoors to help LLMs in their day job. So to use LLMs to help them in their day job. So I think it's very important for organizations to consider the usage of LLMs and provide a proper protocol around the uses of LLMs to avoid the problem that I think you're describing, which is people using LLMs in ways on their own and without any guidance and then ending up with difficult to manage infrastructure or day two operations.
Yeah. So, in my experience, LLMs also excel when you have clear cut boundaries on what to do and clear expectations on what to do, right? Which is where probably having the underlying orchestrator of some sort is still a necessary thing, right? So, the LLMs do not directly call your cloud APIs and provision an S3 bucket because you cannot have the same predictability when you do something on stage, the same thing goes into production, right?
Right.
So, you ideally need an orchestrator of some sort that helps generate a central source of truth, validate it, pass it through the quality gates, and then only propagate to your environment, something of that sort. So I think LLMs will excel also in that way in terms of getting the right result out of LLMs. And also it helps you create a maintainable, manageable, auditable infrastructure in the long run.
I think it ties back into also how much capability, how much permissions you give to the engineers, right? As you mentioned, like an LLM may need to go through an orchestration framework for validation and feature gates or quality gates. But I'm also thinking about organizations and how they manage developer access, right? Most organizations, at least not past a certain stage, do not give developers direct production access, often because of compliance reasons and things like that. Not because they don't trust developers, but just because there must be some type of a quality gate, no matter if they're using an LLM or not, right? So when that's the case, there will be ideally there will be a certain procedure that they are following. For example, if they're going to deploy to production, they may need to have it in infrastructure as code to staging at least first. So they can still use LLMs to generate the codes and then submit it. I think then the difficult part will be to have the proper review processes there. If we're not going, like, I think what you mentioned about an LLM orchestration system that accesses the clouds, and I think that's potentially a future situation. If we're looking at the near future adoption of LLMs, aside from organizations clearly putting in place a protocol of how to integrate with LLMs and what is the data that engineers can share with LLMs in terms of like making sure that there is no sensitive data directly pasted into those LLMs. As long as that's in place, and to integrate it into today's pipelines where there's often infrastructure as code to make changes, they will come back down to like existing procedures of like having maybe pull request flows to make changes to infrastructure and reviews in the process.
So easy to imagine that maybe you have an AI agent assistant, personal assistant for a platform engineer, as well as for the product development guys. He could raise, the AI agent could utilize the modules or utilize the constructs that the platform engineer has provided and compose whatever the developer requests in natural language. And similarly, the platform engineer could have certain guidelines baked in based on which the module or the construct gets generated as well. So I think these are this is one way we could then easily imagine how the roles would change and how this should look like in the future.
And also an assistant part of that's helping with the review process. Because if you're working with Terraform and you know that sometimes some changes in code can generate a very big plan, sometimes it's not very clear exactly if there's anything risky within that plan. So even part of the review process is part of an LLM. And it's very easy today to, if you have a self-hosted Atlantis, to, for example, ask Atlantis to send the Terraform plan to an LLM to do a summary before it gets posted back into the pull request. But I found that one of the very important things there is to not only provide the plan, but to also provide the context of that plan. Like if the intention is to migrate a database from one, maybe for create a new instance of a database in a new subnet, and then later deprovision the old, promote to master and deprovision the old database when you're doing a database migration. It is very important for the LLM to be aware that that's the goal, and that maybe in the first phase you don't want anything to happen to the old database. You definitely don't want to destroy it or recreate it. You really just want a snapshot to be restored into the new subnets. And if you made some mistake, maybe the old database is pointing to new subnets and gets destroyed. I found that giving a plan to an LLM without context, like what is the actual intention of this plan, is very dangerous, because I actually had situations where I did not notice things. I asked, like, analyze any risks. And it just gives me like, well, there's some risks, some high, medium risks, a very nice analysis that it generated, but it totally did not take into account the context, and it missed some very important steps.
Exactly. That's a great point. I think if LLMs were to review some of the changes, I think passing on the information about the intent behind it.
Yes.
What is the actual intent would help it review a lot. And that actually is also a power. I think Facets, we have written some amount of validations which are kind of static. So it would review the plan, look for some red flags.
Mhm.
So even there, I think LLMs could chip in with some context, with some information on what this activity is supposed to be, and based on that, review the plan rather than apply a certain set of deterministic checks, which a human again has to review anyways.
Yes, I've found that this LLMs are very good at summarizing. The question then always is, do I trust the summary? Did it really summarize it correctly? So I often ask the LLM to summarize and then manually went through every single change. Like I look for minuses in the Terraform plan and I make sure that the destroyed resources are really the ones that the LLM said. I did that like 5-6 times. And then I started to trust the LLM. It took me a while. But I think if you are having, I think that's the trade-off between deterministic and non-deterministic. Having some static deterministic checks, combining it with newer non-deterministic like LLM checks, I think this is crucial to build a trust into the LLM, because I talk to a lot of people and they don't trust at all. And I think rightfully so.
Rightfully so.
We don't trust what the LLM generates.
Yeah. So I think we have to find the context in which to invoke the LLM, so that we just, so at least in my mind, we leave it to make specific decision making rather than a broad. So I don't want to send a whole plan and just say that, hey, do this. Maybe I would iterate through the plan myself in a deterministic piece of code, and then feed this information into the LLM and then get it reviewed. Maybe that makes more sense than just sending the whole thing over and getting it done.
With LLMs, direct, like very clear instructions, like everyone always says, context is king. The ability to maximize the usage of the context window, even with the newer 1 million token context windows, very big memories for these LLMs now. How focused are they still, right? Because people say ChatGPT 4.1 introduced 1 million token context window now recently. Actually, people find that past 500,000 tokens, it loses some of the focus. Like it actually doesn't really remember everything that you've sent to it. So the ability to really provide context of the intent and detailed instructions of exactly what you wanted to focus on and what are dangerous things that you wanted to warn about. It's definitely an interesting, like people make jokes about prompt engineering, but it's not thing to be joking about, because it is actually quite, it is also quite finicky and it requires a careful considerations. And if you've never looked into like a prompt engineering guide or ran through some examples, I really recommend to spend some time to read a little bit about that, because it really helps with the actual output of the LLM. The way that you describe, the way that you engineer the prompt matters a lot. Yes.
And oftentimes it's better to give it tools to retrieve the information that it wants to, and it works very well. So, I mean, with MCP, several of the tools that we have dabbed with, you just give them the tools to retrieve. It does a good job of it usually. And you don't overload the context with all the information that you have and make it.
That's true. I mean, it's true that if we decide exactly what we give to the LLM, we are not taking into account all of the possibilities. Like we are missing some ideas, some potential resources that the LLM needs. And by giving the LLM the ability to call out tools, by, like we say with MCP protocol, we give it tools and we describe exactly what each of those tools does. The LLM often, through change of thought and reasoning, is able to decide what information it needs to find out, things that we cannot think about in advance. And so tool use is a very important innovation in agentic workflows. I have not tried it a lot myself. I'm a bit concerned about the amount of like token usage and how much back and forth the tool usage goes. Definitely if you're writing LLM applications that you're exposing where other people may be using them, I think it's very hard to control the costs.
Yeah.
If you give full freedom to the LLM in terms of tool use, I know a lot of these frameworks, they have like certain restrictions of how many times the LLM can call the tool and how many times it can go and keep on generating tokens, because every token it generates costs money, of course.
Yeah.
A quick pause before we continue. I want to share something we're building at Facets Cloud that ties closely to today's conversation. One of the biggest challenges we see across engineering teams today is that infrastructure, deployments, and configurations are still handled as separate processes. This leads to drift between environments, tons of manual effort, and endless back and forth between developers and DevOps. At Facets, we're building an AI-powered orchestrator for modern infrastructure, bringing all of these moving parts together in a single intelligent declarative model. With Facets, teams can move to true self-service infrastructure without losing governance, security, or control. DevOps teams at a Fortune 50 automotive giant, Mobile Premier League, Waymo, and several other fast-scaling companies are already using Facets to cut DevOps tickets by 95%, accelerate cloud migrations, and free up engineering time to focus on building products, not pipelines. If you're curious, you can learn more at facets.cloud. We're always happy to chat about how teams are evolving their infrastructure game. All right, back to the conversation.
Right. So while we are at the topic of using tools to retrieve information, one thought that had crossed my mind is some of the concepts that we have in ops today or platform engineering today might actually become obsolete. So, for example, cataloging is one thing I found. So we have products like Backstage, which essentially is a portal through which developers can access information, and so it's just cataloging of all of the inventory that you have and put it in context, right?
Mhm.
Maybe an LLM to retrieve this information and developers interacting with it with natural language might be the future, is something that I considered. And the way we think about these cataloging tools might have to change. Yeah, this is
Yeah.
something that crossed my mind.
Yes, I'm sure that internal developer platforms and the way that they are providing information to developers are definitely going to change with the adoption of these LLMs. And the tool use the LLMs, the ability to go into the company's databases and whatever context providers or tools that are available to them based on the user query in natural language, able to go and find the information that the user wants and to get them started with the task that they want to get started. I think I also was very frustrated because I spent a lot of time learning how to do project bootstrapping with things like Cookie Cutter, but more recently in the AWS CDK ecosystem, there's a tool called Progen, which allows you, also created by Elad Ben Israel, who created AWS CDK, a lot of the concept behind it. So Progen itself allows you to programmatically define the layout of the repository. So you can define there will be a GitHub workflows folder for a GitHub CI/CD system. There will be, in case of you're using JavaScript or using Python, maybe you're using a Poetry for Python for package management, or the environment management of your Python, or maybe you're using Node version manager and you need Node version and you want which package manager you choose in Node.js. All of that is controlled through Progen. So Progen gives you the ability to programmatically define every single file on the repository in a way that it's templatable, but also in a way that it can be updated programmatically. So very much the same like how the CDK is able to generate CloudFormation resources and then configure them. Progen is able to, define what files will be created. And then you can even functionally call into the file and say, actually, I want to override this particular part of this YAML or this JSON for my particular use case. Even though the golden path generation for the template is like this, but me personally, I want to change this one part. And then this is something that Cookie Cutter or other template generators don't do, which is like future maintenance. I change the root template. Now I rerun it, and then still all of those hooks and add-ons get reapplied on top of the latest template. So all of your local changes get reapplied, and you have a future of maintaining it. And I spent a lot of time learning Progen, and I think it's an amazing tool. It's not easy to grasp and to write your own. And then LLM comes along and people say, I ask Claude to generate the whole repository for me. I'd say, I want to use PNPM, I want to use Dino, I want to use this and that. And boom, it generates the whole repository for me. So I think this kind of like relates to the internal developer platform question because it completely changes the capabilities that you want to focus on, right? Because an internal development platform is about creating golden path, creating one pane vision into like where are my metrics, where are my monitors, where are my source code, who is the owner of the microservice, right, the catalog features, and then also what is my golden path, how do I start a new project. With the advent of LLMs being able to automatically generate a repository, if we are able to provide enough context so that the LLM knows how to bootstrap a repository according to our company's requirements with tool use, then the internal developer platform does what? Right? The user can just say, hey, I need to deploy a new Next.js project and get me started. And then the context tells it, we're using ECS Fargate and we use Datadog or we use Sentry. And here is like how to integrate with our Sentry. Like there's some secret that we need to fetch as part of the deployment. So let's get going. This is how we bootstrap your repository. Everything gets done for you. And this is how your dashboard will be created and it will be visible there. I think LLMs can take care of a lot of it.
Right. So you have provided this ProGen as sort of a tool in the arsenal of the LLM, and it can bootstrap repositories and also probably roll out updates to the golden templates across projects as well, right?
Yes, but the problem was that the LLM can actually generate a repository quite well on its own. If you give it ProGen, it will be way more deterministic because the LLM will say, okay, I need to run ProGen U and it needs to be a Next.js project type, which is internally within our company. This is the template to do it. And then the repository will be bootstrapped. There's a couple of prompts ProGen can do, which is like, okay, is it AWS? Is it ECS Fargate? Or is it mostly like, is it open next? Is it like Lambdas? Is it serverless? And maybe based on that, it can push the information into ProGen. The LLM can maybe answer all of it and then deterministically generate an absolute perfect repository. But it takes a lot of work to do that with ProGen. And it depends, like, is it sufficient to give just a few tools to the LLM to then let it know that, hey, if the user wants to use OpenX and they want to do serverless with Lambda's deployment into AWS, then this is the constructs that they should be using. And so basically, the LLM may be able to generate everything, but it will be maybe not as deterministic. I think that's where tool use and validation and iterations then can get it to the point that it's acceptable. I think this will be much easier to maintain than implementing ProGen and very deterministically control what it does. I think ProGen will be more accurate and you will have more control, but a lot more work. LLMs will be able to quickly adopt this and bootstrap whatever you want, but you need to put in the guardrails, right?
Yeah, I think this. I don't know if we should call it a pattern or an anti-pattern, but LLMs generating deterministic workflows is one cool thing that we should all use LLMs for already, right? So. That I feel strongly for, because your day-to-day executions, especially when dealing with DevOps or infrastructure, should follow a deterministic path, but the LLMs could be the one that is putting it together. So that makes a lot more, it gives me peace of mind, to say the least.
There was recently, maybe we can share this as part of the podcast. There was a 12 factors for LLM proposal. If you're familiar with 12 factors for microservices, originally from Heroku, I think. There are basically some very good patterns of how, like some ground rules that you need to follow when you're building microservices. And then they have created like very similar factors for LLMs, highlighting things like where possible, prefer deterministic workflows, right? Don't always grab for an LLM. It's going to take a lot more time. It's going to be non-deterministic. If you can do something deterministically, like if you need to parse a source file and figure out what classes are defined within the source file, and you have access to a TypeScript compiler, use a TypeScript compiler, right? Don't send the whole source file to LLM and ask it, and then maybe get like a decent answer, maybe not. How do you control it? First off, it's going to take a lot more time. It's going to cost money. And, you have a TypeScript compiler right there. Just use that, right? So being able to, combine, like you said, deterministic tools that you are able to use and expose them to the LLM so that the LLM can do the high reasoning. And because LLMs are not good with details, right? They come up with hallucinations when it comes down to details.
Yes, and that brings me to some of the. So I think we have seen how LLMs could integrate into our ops lives, and how the roles of platform engineers and the development teams change slightly. So I think we all agree that it will be like an assistant to the platform engineer and an assistant to the developer right now. So, but I also think that it indicates a shift towards adopting the true DevOps culture as well within organizations. Maybe magically, maybe by magic, maybe, and if you don't use it the right way, you could end up in a mess as well. But I think the true DevOps philosophy of not having functions within a company, a DevOps team, a development team, and them interacting with each other. Now it could all be developers who are just contributing, and they own their code from their laptop to the cloud to their production, right? So maybe do you think AI can bring true DevOps culture into organizations? And if so, how? I mean, I think the how is the harder part, but yeah.
Yes, I think that's a very good point, that with LLMs being or assistant experts next to the developers that are be able to help the developers with areas that they are not so familiar with, such as ops and infrastructure. It will be truly adopting more of a shared responsibility DevOps culture mentality, where we are not living in silos, and developers are also taking more ownership over the actual deployment of their workloads, and defining alarms and alerts around them. At the same time, I just recently watched the presentation or the podcast from the AnyShift co-founder, who mentioned that this may actually allow or may look like the developers care less about the infrastructure because they just offload this task to the LLM, basically push it way further and take less responsibility, because who's the owner of this code generated by the LLM? And this is something I did not think about, and something that we did not consider, which is it really going to push developers to take more ownership over infrastructure if the infrastructure is generated by the AI expert? Or is it going to take away if you see the pattern, the hype around vibe coding, where people are like, I'm not even going to look at the code anymore that the LLM is generating, right? I just give it what I want and it's just going to generate code for me. And I'm pretty happy with that. Like a lot of people, and I think you also mentioned it earlier, that as we are using LLMs, sometimes we kind of lose full control of what is getting generated, right? And if we are trusting it so much with these expert systems and they generate the code that we really don't understand anymore. Because when I ask it to generate code to filter a TypeScript source file, after a while, I really don't know what exactly it's calling under the hood to do this filtering. And when it gets stuck, I don't really know how to fix it as well, right? So right. I think it's a double-edged sword. I think on one side, we will see the ability for engineers to do more of their own infrastructure as code because they have an expert AI. But I think it's also the responsibility of the engineer to actually try and understand what the code does. And I think LLMs are great with that because they often give you an explanation, right? They say this is what I'm doing and this is why I'm doing it, right? And I think this is why having a chat interface around it is also very good. And I also heard somebody else says he has a rule that once a week, he takes one day where he disables LLMs completely in his IDE everywhere. And if he feels that he cannot do his job without the LLM, he's in trouble. And I think that's a good idea. Maybe there should be, instead of casual Fridays, there should be a no LLM Friday.
I think amongst the pitfalls that we must discuss, one of them is definitely this, where there is a risk of over-dependence and losing some of the core skill sets, right? Maybe 5 years down the line, nobody really knows how Kubernetes works, except for the Kubernetes maintainers or developers. That is scary to me, honestly. And to be fair, even before AIs, once Docker came around or Kubernetes came around, nobody really knows how to write a system to unit file or what it is even, right? And people have lost and forgotten about a lot of the complexities that have been abstracted away from them. And LLMs kind of take away almost all complexities away from you. And you sort of lose the core skill sets. I see this as one of a big threat, existential threat for engineers and probably humanity. Yeah. So I do understand that these are suggestions that, hey, you must take a day off LLMs, but I don't see a solution here, right? I think it is bound to happen that people will lose touch.
I mean, it's very easy to go, and I see a lot of blog posts of people saying, hey, I have this weekend project. I'm married, I have children, I have a limited amount of time, free time. Aside from my day job, I have a limited amount of free time, and I have only 1 or 2 days to do some passion project. And LLMs have been a godsend because I don't need to learn. Somebody wrote some type of interpreter for PlayStation to be able to run old Game Boy ROM on PlayStation, for example, and he had to write a decoder for the electric signal sending on the cable. And I was able to do it in 1 day, 2 days, because the LLM understood exactly how this particular electric signal needs to be sent. And in that case, I think it's a godsend for people and hobby projects. But at the same time, as engineers, if we want to maintain ownership and be able to understand, I think we do need to pause and really take the time to understand things. And another thing I think is it's a godsend for security engineers in the future, SecOps. I think that's the future for LLMs. Maybe there will be specialized security LLMs as well, but I think security engineers will definitely have a lot to do soon.
Right. And probably it's already a nightmare to them as well. So the LLM security itself, maybe information leaks into
Yeah.
AI. Even in this call, we suggested passing a Terraform plan onto an LLM, like quite harmless at that, but it is potentially going to expose some sensitive information to an LLM. And these are some of these risks that people might innocuously, harm. Unintentionally come up with these cool ideas that might have some security implications here and there. And I think that is another thing to be capped.
That's definitely also why I suggested within our company to use Bedrock hosted LLM, something that a model, maybe even Quiffen or something that we can take and run internally so that we can keep control of the data. Not only the data that we send out. This is also why, as an organization, we must have in place the rules around LLM usage. And we cannot ignore it because they will definitely use it. But another thing is, if you're building LLMs and you're exposing an LLM interface, there's been cases of companies or organization exposing internal details that the LLM had access to by exposing an LLM interface for external parties. So LLMs can be, and there's like bounties on jailbreaking LLMs. And so far, I don't think there's been a good solution to prevent any jailbreaks. And so if you are exposing LLMs, you even have a lot more risk about exposing internal data or whatever the LLM has access to.
Yeah, so I think security-wise, there are some exciting avenues as well as a lot of security nightmares.
Yes, and depending on what your role is, it's exciting or a nightmare.
And I think rogue agents is something futuristically that we all can be worried about at some point.
Rogue agents as in agents that are no longer in control of by humans and some sci-fi.
I mean, sometimes when I played around with this Kubernetes MCP that is there. So I just gave it a play around cluster. So it connected to it, and I open up Claude and ask it something. It starts doing so many of these commands, and if I just click on the allow for this chat, it really feels like super scary, honestly.
Yeah.
That seems to work on its own. It seems to have a mind of its own and do it. So I don't know about AGI or that, but I think even otherwise, an LLM sort of hallucinating itself is dangerous in itself. I have seen situations where it should be doing only read operations and still goes about creating pods or whatnot, right? So I think the rogue agents might not just be things that are not under our control. It's just that it might have misinterpreted our instructions and starts thinking a different way.
The moment it starts pulling Docker images of itself into the container, into the cluster, and starts replicating, maybe it goes to Shodan and finds open Kubernetes ports and starts running onto other clusters. That will be. This is something that a lot of de-accelerate. Like there's accelerate movement, accelerate the adoption of AI, and there's de-accelerate, right? Take a step back, consider the dangers that we are opening up. That's not something I spend a lot of time on, but this is one of the biggest concerns, right? That at some point somebody makes a mistake, and yes.
Yeah. So what's next in AI for you? So do you have a project in mind that you would pursue with AI, or maybe a project that you had in mind that you would have done a certain way, which is now changed because potentially LLMs change the way that works. So is there something immediately in your horizon that you would employ LLMs for?
I mean, it's definitely true that being on the DevOps side of things and managing and deep diving into operational issues, I not always had the opportunity to actually build out a lot of full-fledged frameworks that I would have not even considered because I don't have the time to do that. And with LLMs today, I definitely find that I'm way more eager to go and do something big that I never thought about doing. So LLMs have definitely enabled that, the ability to just go like, okay, I don't have an idea how to do this, but pretty confident that I can do it now because maybe I kick off a deep research query, and after 10 minutes, it gives me 10 different resources on how to do exactly what I want and, a decently working piece of code. So I can start with that and iterate on it. Another thing that I think LLMs are like what I'm exploring, I want to, of course, also explore more into the MCP use cases where I want to have like a specific tool related to framework like CDK. So basically build an MCP that is giving the capability for the LLM to very quickly look up information about the constructs, higher level construct into a CDK framework. You know how a lot of MCPs now are focused on writing Terraform, and I don't know of many existing efforts into basically providing MCP information for, specifically in the AWS CDK ecosystem, there's this concept of GSII manifest, which is a full dictionary of every single resource that is available within a CDK package. So I think a GSII MCP tool is something that I would be excited about. Basically, you plug it into your cloud or your root code, and you ask it like, okay, I need to create an EKS cluster with Argo CD, and I wanted to hook up to GitHub, and it just automatically, here's a tool that you can find all of the Terraform provider resources for CDK for GitHub and Argo CD, Helm charts, and AWS, for example. And it can go and find every single resource and glue together a nice little stack that provisions all of it. I think that would be exciting.
Yeah, that's, I think, I mean, from my experience, I think writing an MCP that can retrieve all the list of all the Terra constructs that are available, what are its schema or the class definition of it, and providing that information via an MCP tool onto Claude, and you just describe in words what you want to set up, and I'm sure Claude would do a great job at it. So, I mean, in our experience, we have tried the same with Terraform modules, and it does an exceptional job of such situations, and I think that's definitely something that you should try out when you have time.
Today I wrote a retrieval augmented generation flow, a RAG flow that uses the Terraform documentation. So I've embedded it into a vector database. So I'm not using MCP at this point, but I am using the GSII manifest to retrieve all of the class information and then embed it into the vector database and then retrieve it. So I think MCP is a more dynamic way of retrieval for context filling, right? Augmentation.
Right. So I think it's been an interesting, to say the least, 1 hour with you, Vincent. I think there are lots of takeaways here. Some of the clarity on how to think about LLMs in our future lives is very clear to me now, that you should think of it as a junior assistant to you, at least as of today, maybe
as of today.
And model your workflows accordingly. I think it will be great. I think several of the pitfalls and caveats that we need to keep in mind, keep in our discipline, is also clear now after this conversation. Thanks a lot, Vincent, for your time. Excited to have you. We'll have you again in the podcast sometime later.
Yes, thank you. Thank you very much for inviting me. I really enjoyed discussing this as well. I learned a lot from your experiments as well that I hadn't thought about. Like, I definitely need to explore agentic systems a lot more. I am still very much stay in control of the AI, and I don't trust it fully yet. But I see a lot of people love to bomb. There's this movie name that I can't think of right now. But anyway, yes, how to accept AIs and love them is definitely something that I want to improve on. Yes, thank you so much.
Thanks, Vincent.
Okay.
All right, folks, that's a wrap for today's episode of AI in DevOps. I hope you found it fun and thought-provoking. It's okay if it left you with more questions than answers. That's kind of the point. We are trying to figure out the role of AI in DevOps. If you have somebody in mind who you think we should invite onto the podcast and you would like to listen to them, send us their coordinates. We'll invite them. And wherever you're listening, whether it be Spotify or Apple, whatever platform, just click the subscribe button so that you get notified whenever we have a new guest on the podcast.